Hey everyone, this is Mr. Jacobs. We are discussing Learning Target T Lesson 10.3 on basic probability and experimental probability. And I wanted to start by giving you just a basic definition of what probability is. You can think of probability as being a number between 0 and 1 that tells you how likely something is to occur. And we're actually going to jot some notes down here. The first definition I'm going to give you is the way we can calculate probability under the circumstance that all of the outcomes in an experiment are equally likely to occur. In that case, the theoretical probability of event A is the number of ways that A can occur divided by the total number of possible outcomes. If you look at this diagram, you'll see that we have a Venn diagram. Event A has 3 objects, and all of the possible outcomes include the 4 that aren't in A, as well as the 3 that are in A. So you would have a probability of 3 out of 7. Now, that makes probability fairly easy to calculate for examples like example 2. Suppose you reach into a bag that contains 4 yellow marbles, 5 green marbles, and 6 blue marbles. What is the probability of choosing a blue marble? Well, if we want to find the probability of choosing the blue marble, then we have to know how many blue marbles there are. And they gave us that information, so we can write down that there are 6 blue marbles. But we also need to know how many different marbles we could grab. And if we add these together, there are 4 plus 5 plus 6, which is 15 total marbles. Therefore, the probability of blue, and I want you to notice how I'm writing this. Capital P, like function notation, the probability of blue, in parentheses, is going to be 6 out of 15, which is an unreduced fraction. If we reduce this fraction by dividing both the top and bottom by 3, we get 2/5, and we can use a calculator to convert that to a decimal, which is 0.4, or move the decimal 2 spots to the right to write it as a percentage, 40%. We can express probabilities as fractions, decimals, or percents. So any of these answers would be considered correct. So if you'll flip the page in your notes, we've got an example on the top of page 3. It says we are choosing a random integer from 1 to 80. So of course there are 80 numbers here. We should make note of that. There are 80 numbers from 1 to 80. And we want to know the probability of getting an odd number. Well, the odd numbers would be 1, 3, 5, 7, and so on. It's every other number. So there's going to be exactly half of the numbers are odd and half the numbers are even. So our probability, half of the numbers from 1 to 80 are going to be 40 of the numbers. So there are 40 of these odd numbers. So our probability is going to be 40 out of 80, which of course reduces to 1/2. So I would like you to take a minute and answer question number 2, question number 3, and question number 4. The other topic within basic probability is experimental probability. And experimental probability are for those instances where it's difficult to calculate the theoretical probability by hand. The experimental probability is when an experiment is performed that consists of a certain number of trials. The experimental probability of an event A is given by the number of times that event A occurs divided by the number of times that you did the experiment, or the number of trials. And that brings me to a concept that's not listed in your notes that you might want to pause the video and jot down. It says the law of large numbers states that as the number of trials gets larger, the experimental probability will get close to the theoretical probability. That means if you were to flip, let's say, 1,000 coins, you should get heads roughly half the time. So the more and more times you flip the coin, the closer you'd get to the actual probability of heads, which of course is 1/2. Let's look at a quick example here. You spin a spinner 24 times. Alright, right there is the number of trials. That's going to be the denominator in our probability. We want to find the probability in part B here of landing on a primary color. Well, the primary colors, of course, are red, blue, and yellow. So if we look at those values, red was 3, blue was 5, and yellow happened 3 times for a grand total of 11. And we did the experiment 24 times, so the probability of landing on a primary color, so probability of primary, is given by 11 out of 24. But when we're dealing with an experimental probability, we don't typically leave our answer as a fraction. We tend to use decimals or percentages because they're not exact. They're approximations of what the real probability would be. So we do 11 divided by 24 on a calculator, and we get the decimal approximation 0.458, which has been rounded off, or 45.8%. So fairly simple to do. I would like you to try example 4. So give that a shot, submit your answer. And that concludes my video.